Okay, Math 3, we're going to solve exponential equations two different ways. One way we're going to solve it just by rewriting the bases so that they're equal bases, and another way we're going to solve it with logarithms. So this is the no logarithms way. We're going to find two bases are equal. So what we recognize here is that if the bases of two exponents are equal, then we know the exponents must be equal. So right here, 7 and 7 are both the same, so we know x has to be equal to 4. All right. Down here we look, 5 and 5 are both the same. So because they're the same, the two exponents must be equal. So I write an equation that says they're equal. And once I write an equation that says they're equal, then I just solve that equation like I would normally solve equations. Alright. Come over here, same thing. I see 3 and 3 are the same. So that means the exponents must be equal. So once I write an equation, I'm able to solve that one like I would normally solve equations. And I'm going to skip that part, but you guys can distribute and solve on your own. Okay, that's one way of doing it. Now the problem becomes when sometimes they're not the same. I look at these and 4 and 16 are not the same. So what I'll do is I will try to rewrite them so that they are the same. I can rewrite 16 as being 4 squared. 4 squared and 16 are exactly the same number, so I just take the 16 out and put 4 squared in its place. Now, there's still that power of x minus 5 I have to deal with. But if you look now, you'll notice, hey, I've got bases that are the same. So that's a good thing. Now, as a reminder, when you have a power raised to another power, our laws of exponents tell us to multiply those. So that's going to be 2 times x minus 5 is 2x minus 10. And now you can clearly see they're the same. And again, you can solve that on your own. Alright. Same issue over on this other side. I'm going to rewrite. Now this one was trickier because I couldn't get the 8 and the 32 to match up exactly, but I could get the 8 as a 2 and I could get the 32 as a 2. Alright, just review your powers of exponents, but 2 to the 5th power is 32 and the negative makes it a fraction. That gives me this, and I use my powers of exponents. I realize that 3x plus 12 will equal negative 10. And at that point I can solve just using my normal techniques. Alright, so you got 1 through 8 on the back of this sheet. Give that a try. The answers are on the board, but you guys are welcome to check those out. In a minute we're going to try to solve them when they're not the same. Alright. What we're looking at now is we are going to do these so that when they're not the same, but before we do that I want to really look at what it means to be an inverse. If I take the inverse of an exponential function, then all I have to do is switch the x and the y. So when I rewrite that, I switch the x and the y, I end up with this equation, x equals b to the y. And if you'll think about that, that's yesterday's notes. That is exactly yesterday's notes. That is the definition of a logarithm. Alright? So the definition of a logarithm is the inverse of an exponential. So that tells us exactly what I wanted to know right here. That the inverse function of an exponential function is a logarithm. So over here we're going to look at the graph of a logarithm. This yellow graph here, that's our exponential function. We did that on Monday. So if I reflect that over the line y equals x, I get the exponential function in green. So just to check out the domain of that, it's everything bigger than 0. Notice it never goes past 0, so it's everything bigger than 0. Now the range is all real numbers, because I can use everything down here and everything up here. Now, on the opposite side of that, just to remind you of the exponential, what the domain and the range looks like, right? Alright. Doesn't have an asymptote. It does have an asymptote. Remember, the asymptote is the y-axis, which is the line x equals 0. That's this axis right here. And it does not have a y-intercept, but it does have an x-intercept at this point 1, 0. Now, the reason that we did that was because we were trying to make sure that we understood that it was an inverse function. So we come over here, and we're going to do our inverse functions. Now, this particular problem that's right here, I don't need to do the inverse function. I can actually just do it the same method I did before. By rewriting that, okay? I can just rewrite that just like we did, 3 minutes ago. So I don't need to do this one with logarithms. Let's find one that we do need to do. Alright, we're going to jump down to this problem here with the 7. If you'll notice, okay, I can't make the 7 turn into a 20, right? So I can't rewrite the base. So what we're going to do is we're going to write it as a logarithm. So like I did yesterday, change this to a logarithm. This is going to be log base 7 of 20 equals 3x minus 4. And that's really nice because I can do log base 7 of 20 in my calculator. So go ahead and type log base 7 of 20 in your calculator, and you get this decimal. And I hope now you see it's really just a solving problem now. So once we've changed it to a logarithm, we can solve it with our Algebra 1 skills. We'll try that again one more time here. Change it to a logarithm, okay? Now notice this one was a common log. It was a base 10, so I just wrote common log instead of writing a log with a base. Alright, I put log 150 in my calculator and I get this decimal. And now I use my solving skills. Alright, and my solving skill is just add 5 to both sides and then divide by 2. You should be able to find this. If you got any questions, let me know. We'll deal with the word problems tomorrow, so for right now, just deal with 1 through 8 on this side as well.